Bismillahirrahmanirrahim. My name is Hassan, and in this video I will explain you the Zumo simulation in Proteus 8.10 with an SD card interface with this. Okay, so you can open this simulation from file, open sample project, and in sample project there is a project with name of Zumo. Okay, Zumo is basically a line follower with Maze Solver Robot. Okay, so this is basically the schematic of a Zumo built in available in Proteus. Okay, so first of all I will explain you how you can basically add path in this Zumo robot, and how you can add an image file in which the data is saved on the SD card. Okay, so first of all in Zumo you need to give this Zumo a path. Okay, so I have downloaded a path from internet, which is here, which is basically provided by our instructor. This is the path. Okay, we have to follow these lines. So how you can add this path? This is the png file. Okay, you can add this file by clicking on the right click and then obstacle map. Okay, in obstacle map you have to put that file in this. Okay, I've already given this file to the Zumo. Okay, so the next step is how you can add an image file in an SD card. In this you need to download WinImage software. I will also provide the link of this software in description. You can download from there and install this software. Simple installation process. When you have downloaded this software, you will open this software and go to, I will show you something. Wait, go to new. This will create a new image file. I have already created an image file which is here, SanDisk MMC 128 MB. Okay, first of all we will close this simulation, so you can see here how it will open. This is showing the size of the file, which is 12 MB approximate, and this is basically the layout. In start you will not see this file here. Okay, you have to inject this test.txt file in this WinImage, or you can say SanDisk image file. You can go to image, inject image, and you have to add this file here. I have already added, and I have taken the readings as well on this. Okay, so I will firstly delete this file because I have to take new readings. Okay, so I will inject this file, test file, from here and open this. Okay, so now you can open this and you can see it's a blank text.txt file. Okay, so now close this, all this, this one also close. Now open the simulation. Now I hope you will understand, you have understand how to create an image file. Okay, now in the simulation you have to right click on the SD card, edit properties, and here you have to put that image file, which is SanDisk MMC 128 MB. I will also provide this file with the simulation. So now we have to run this simulation and let's see what happens. Now you can see here modified Zumo line follower SD card initialized. This is representing that SD card is found in this SD card module, and it is also initialized. Now our robot is ready to start. Okay, So there is another scenario when SD card is not inserted. Suppose we have taken out the SD card. Let's see what happens. Now the SD card is out. You can see here modified Zumo line follower initialization failed, error opening test.txt file. Okay, now you can see here when the SD card is out, initialization is failed. Okay, so you have to insert an SD card for before running the code. So now we have inserted SD card. You can see SD card is initialized. Now you need to press the button for Zumo to start. First of all, it is calibrating and detecting the black line by moving to and fro. Now you can see it is following the basically the leftmost sensor and the rightmost sensor decides whether to move right, back, or in left direction. Okay, so and the center four sensors basically for detecting this T, or you can say detecting this endpoint. Okay, so there are basically 6 sensors array. You can see here the every turn which is turned by the robot is noted here in virtual terminal. Also it will save in SD card. We can also see this after closing of this. So this is how it ends. Now let's go to the SanDisk file. Okay, when you open this, here is the test.txt file, which is initially when we have entered a new file the size is 0, but now the size is 80 because the data is saved. There is some flaws in my laptop, so sometime it's give errors. Okay, now here is the basically the turns which are turned by the robot are noted here. In this way you can utilize this data for performing a better robot. Okay, now I will again open the simulation and let's see. Now we will cover the code, how it basically works. Okay, so I've explained the simulation and now it's time for the code. In the code you can see here that there are different headers file which are used. qtr sensors.h, Zumo reflectance array sensors.h. These all are file for the header file for the sensors. You have noticed here that there are 6 sensors which are attached to these pins. Okay, we can also see how the pins are basically attached when we go to the Zumo reflectance sensor array. Okay, here the pins are basically initialized. Here sensors pins. Okay, first of all 6, A3, 4, A0. You can see here IO6, A3, 4, A0, A2, A5. Okay, all these pins are mentioned in the code as well. Okay, we will close this. So this is basically our main code. Okay, so our next header file is Zumo motors.h. Similarly Zumo buzzer.h, push button.h, and there is sd.h and spi.h. sd.h is basically for header file of an SD card built in header file. Okay, and spi.h is for SPI serial communication. Okay, there are different protocols, but here we have used in an SD card we use basically SPI protocol. So there is file, my file, basically an object is created of my file type in an which is basically the SD card which is included in the SD card code. Now there are different definitions when defining the some values which is for our easiness basically. The sensor threshold value is 300. Okay, so above line is when considered when there is the sensor value is greater than the threshold value, which is 300. Okay, so there is another definition, which is turn speed 200, which means the turning speed will be 200, and similarly this normal speed will be also 200. Line thickness is also mentioned 0.75 inches. Similarly, inches to Z units, which means Zumo units. This is the calculation which is done by approximately every inch there will be approximately 17142 Z units. So this is basically a conversion. So defining our should value, this means when the line is thickness is increased, this will happens in case of a T shape line or at an ending point. Okay, so Zumo buzzer in start, you have noticed that there is a buzzer beep. So this function is basically for the buzzer. Similarly, Zumo reflectance array reflectance sensors. This function is also basically from the Zumo reflectance sensors array header file. Zumo motors, this is basically from the Zumo motors.h file. Similarly, the push button is at 14 pin. You can also see in the schematic. Here is IO 14 button is statue IO 14, so I mentioned here 14. Then there is a path array of size 100. Okay, then there is a variable path length of char data type, which is equals to 0. Then void setup, we have now entered into the setup loop. In this we have written serial dot begin 9600 serial dot print ln modified Zumo. This will just simply print on the serial monitor. Serial dot print ln is basically for the serial for writing something on the serial monitor, or you can say virtual terminal. Then there is another when serial does not equals to, then it will go to this loop. But in if the our SD card is attached with this with the pin, then it will go to this and see whether the CS pin of SD card is attached to 10, chip select pin is attached to 10 or not. If it is not attached, then it will print out this the virtual terminal that initialization failed. Okay, you can also see here the SD card chip select pin is attached to IO 10. Okay, so same pin is here IO 10. Now we have a built-in function which is present in sd.h. For writing something, you have to follow this syntax. My file equals to sd.open test.text file write. File write is basically for writing a file. File reading is read is basically for reading any file. So here is the file name test.txt. We have also because this name is also in our text file test.txt. Okay, so now if my file is found, this means if the file is opened, then it will go to this function, this if condition. In this you have to write the turns. First of all, turns on the top of SD card. Okay, then serial monitor pe we will display SD card initialized. Because SD card is open, this means SD card is also initialized, so this will print out this. Then we will close the my file, which is basically the SD card file. Now if this is not open, then else, which is displaying error opening test.txt file. This means either your file is not there in the image file or your SD card is not there. Okay, Now you will come to the Zumo code, Zumo test 1. Then there is a sensors array, count variable, last status variable, turn direction variable. Then there is a buzzer.play function which is included in the Zumo buzzer.h file. This is for basically in the start the Zumo will beep. Then there is a reflectance sensor initialization function. Then there is also a motor speed function which is initialized with 00. Then there is another LED which is attached to the 13 pin, which will glow in the start. Button dot wait for button. This means this function will wait for the button to press, and then it will start the remaining code. Okay, so calibrate the Zumo by sweeping from left to right. This means in the start you can see here in the simulation that our robot will move right and left, okay, for better detection of the black line. So when it is 1 it will move clockwise, when it is -1 will move and counterclockwise. So there is a count variable, reflectance calibration function. Then there is a reflectance sensor dot read line sensors. Basically it will this function will see the output of each sensor, and it will detect the line. Okay, so turn direction is less than 0. If the turn direction is less than 0, then it will go to this function. If the basically our rightmost sensor and leftmost sensor are detecting either to move right or left. Okay, so in this way there is different two conditions: turns direction is less than 0, and otherwise it will go to this. If the turn direction is less than 0, then it will basically sensor 5 is high. Okay, so similarly if it is not, this condition is false, then it will consider sensor 0, which is the left sensor. So now count is equals to 0, last state is equals to 0. Last status is basically for detecting, or you can say for moving back. Okay, which turn is taken once, then it will not taken again. Okay, in this way we can go to the our destination, or you can say final point. Now there is another turn left function in which our both speed is initialized with 00, and our LED will be low. Now our main loop function is here. First of all, I initialized or you can say open the SD card file with this command, or you can say function solve maze. There is a function called which is solve maze. It will basically explore every segment of the maze until it finds a finish line. So this is the important main function which is named by solve maze. We can see here this is the basically function solve maze. In this there is a while loop which will run infinite times. Then there is different variable: found left, found straight, found right, initialized with 000. When it is 1, this means you have to move left, and this for this, when this found straight is 1, then you have to move straight. Then if the found right is 1, then you have to move right. Okay, so in this you can see here there are different conditions. You can see above line sensor 0. If the line is on the sensor 0, then you have to move left, because sensor 0 is left sensor. Okay, similarly if the right sensor 5 is on the line, then you have to move right to be on the line. Okay, so that's why if the sensor 0 is on the line, found left equals to 1. If the sensor 5 is on the line, then found right is equals to 1. Okay, so now there is a delay function, some delay. You can take this delay, which is basically the overshoot value, which means for better this is basically for better smooth motion of you can say our robot. Now there is another condition. This is basically the same one as mentioned above. There are basically the you have three conditions. Okay, first condition is your sensor 0 is on the line, then you have to move left. If sensor 5 is on the line, then you have to move right. Then there is another condition in which you have to move straight. In straight you will see the from sensor 1 to sensor 4. Okay, these four sensors will detect either to move straight or moving back. If all these if any of these sensor is on the line, then you have to move straight. Okay, similarly there is another condition for basically stopping of stopping at final point. This is when all these sensors are giving one value or on the black line, or you can say on the black line, then it will stop the robot. Okay, so this is basically our solve maze function. In this way we can reach the final destination. Then there is another solve maze. Then there is a buzzer dot play function which is included in the buzzer file, which will basically beep when the robot is start. Button wait for button, which is basically for it will wait for the button, and at the finish line, when it reach the finish line, then the buzzer will also play. Okay, so there is another function which is named by turn char directory. dir is basically a variable of data type char, and in this function basically we have again three variables: count, last status, sensor 6. Sensor 6 is basically an array of sensors. When there is a switch case statement, when direct dir is L, then you have to enter this case L. In this you have to you have different cases. Case B is for moving back. Similarly case right is for moving right. In this you have to just change the one motor direction and the other motor direction for motion. Okay, for example, if you want to move right, okay, this means you have to run the left motor forward. This is the left motor, it is moving forward, and the right motor moving anti-clockwise. So there is a minus sign which is basically for anti-clockwise motion. Okay, it will multiply with the turn speed, which will give it minus 200. Okay, so there is another case for straight motion. Straight motion we have to do nothing, and there is a break condition, it will come out of the loop. Then there is another function Selector, which means you have to select which direction you are moving. Okay, so it will depend upon found left value, found straight value, found right value. If found left is 1, then it will move left. If found straight is 1, then it will move straight. If found right is 1, then it will move right. Okay, so if found left is 1, then it will move left. So you have to print this left L on the serial monitor, and similarly on the SD card file. Similarly in this straight case, you have to move S, you have to print S on the serial monitor as well as on the SD card file. Similarly for right, you have to use R. Similarly for back, you have to use B. Okay, so in this way we are saving our turns of the robot in an SD card as well as on the serial monitor, you can say virtual terminal. So this is basically the one of the simple, you can say, explanation of this Zumo line solver robot with modified form, which included the SD card simulation. Okay, so all this code is explained. Now I hope you will understand this. Okay, if there is any question, feel free to contact me in the comment section. Thank you so much for listening.